we saw out there. Let's see if Miss Lowe's can use her technology skills that she really doesn't possess. It's supposed to be zooming. Oh yeah, there we go. Make it a little closer. Can y'all see that? Can y'all see that? Good enough, maybe, for us to have a discussion about? Let me get a little higher. So, what do you notice about all these pieces? Is this what you all got? Do you all agree with this answer?
Yes.
So here's what I want you to talk about at your table. Okay, there should be a light or something. Let's do that. I need to pop it up. All right, so talk at your table. How do they know? Why do they have 1 in the numerator of each one of these? Talk at your table. Why do they have 1 in the numerator of each one of these?
Because they all have a piece of a whole. They all have
Okay, come back with me. Talk to me about what you and your partners talked about. Why is there a 1 in the numerator of each one of these? What did you talk about back there? Oh, did you hear what he said? Who can tell me what he said? What did he say?
It's only one piece out of the whole.
It's only 1 piece out of the whole. Would y'all agree with that? So the numerator tells you how many pieces that you have, right? So we only had 1 piece out of the whole that we were talking about. So now then we have the denominators where there's a 2, a 4, a 3, a 6, a 12. Talk to your groups about why are those all different? How do we know that this is a half and is a 2? How is this a 4 than a 4? Why? How do we know that? Talk to your table. The 1 tells you how many pieces out of the whole you have. All right, come back with me. Would you mind sharing that thought? Tell me. Zoe has a thought about the denominators and why they're all different. Can you tell us what you're thinking? Do y'all hear what she's saying? That's how many will fit in the whole. Would you agree with that? So if we were looking at this next picture, and it's moving slowly but surely, how many halves are there in a whole? 2. How many, and it's hard to see, but how many thirds are there in a whole?
3.
How many fourths are there in a whole? 4. How many sixths? 6. And how many twelfths?
12.
It's kind of hard to see that. Let me see if I can zoom in. Maybe not. Can you see that? A 12 there. And so all of those, the denominators tell us how many would fit inside the whole, right? So numerators tell us how many we're talking about, and the denominator tells us how many would fit inside the whole. By the way, what was the whole? What was the whole? Hold it up. What was our whole? What was the whole? Ah, the yellow hexagon, right? What if we change the whole to something different? What would that do to all your pieces? What if I said this was the whole?
The yellow one would be 2 holes.
Ah, it would be, wouldn't it? Yeah. So we would have a lot of things to talk about. We're not going to do that today. Keep that in mind when you think about that. If we change the whole, it does change everything. So let's go back to the PowerPoint. And remember, we're working on equivalent fractions today. So you found some equivalents for the whole. I want you to write the equivalent fraction. You and your partner, write it on your board while we're going back to this. What was the equivalent fraction for 1 whole when 12 was your denominator? Talk to your partner. What would that fraction look like?
Stop touching it.
So what would the whole be? If I said use the denominator of 12, how would you write a whole?
I need 3 of these. So 3 of these.
Right. So what would represent the whole? How many 12s? How many wholes? How many pieces would it take to make the whole? It would take 6 of these? You're saying 12 of these? You're saying 6 of these. Which one?
12.
Okay, so back with me, I heard a lot of people, this is what I saw and heard you talking about, that if we were writing a whole with a 12 as our denominator, there would be 12 in the numerator. Why? Why would there be 12 in the numerator, Chloe? You're not Chloe. You are, you left me, I don't know. Isabel.
There would be 12 to like because it would have to be like equivalent for it to make the whole thing. If there was one missing, then it wouldn't be like the whole thing. You would need an X. You would need one more to make like the whole thing.
So when she says make the whole thing, what does she mean by that? What does she mean by that?
Make one whole.
Make one whole? What is she doing to the whole with these little things? What is she doing with it? To it? Talk to your table. What is she doing with these little pieces to this whole to show their equivalent? Talk to your table. Tell me. What is she doing with them? What's she doing with these little pieces to show this is equivalent? That there's 12 of them. Putting them on there and figure it out. Okay, so come back with me. I heard it back here somewhere, and I heard it up here. How's she figuring out that it takes 12 of those to cover the whole? What is she doing? Yeah, close. She's putting them, okay, so when she's adding them to the whole, what did you all say in the back? What is she doing with the pieces? I heard it back there. What does she do with all these pieces? Yeah.
She's putting them on the hexagon to make them equal to the whole.
Did you hear that? She's putting them on the hexagon. How does she know it's equal to the whole? It has to do what? Cover it all, right? So they're equivalent when they cover the whole thing. And it takes how many to cover the whole thing? Well, so now that we're talking about what it takes to show that it's equivalent with your model, don't forget the second part of our success criteria, which is to think about an equation that would show that. So now I want you to explore with your partners to find equivalent fractions for 2/3 and for 2/6. Okay? So remember, everybody hold up at your table. Show me 1/3 of your pattern blocks. Which one was 1/3? So how are you going to make 2/3? You're going to put 2 of those together, right? To make 2/3. Show me 1/6. Hold up the pattern block that represented 1/6. So how are you going to show 2/6? You're going to put 2 of those together because the numerator tells us how many pieces, right? And the denominator the size of the piece. So now, knowing what you know and exploring about equivalency, I want you to find a fraction that is equivalent to 2/3 and another fraction that's equivalent to 2/6. You and your partner work together. I want to see it written, I want to see it modeled, and I want to see an equation. You got about 5 minutes to work on that. So what fraction are you working on first? 2/3. So show me 2/3. Oh, I forgot your questions. I'm so sorry. Miss Lovelace forgot your questions. I told you there would be questions. There they are. So these are the questions you need to talk about with your partner to keep you, when I'm not around. These are the questions. Remember, part of my expectations were that you had to be able to answer those questions. So these are some things. You're going to be doing this, finding equivalency for these. But I want you to be able to answer these questions. What happened to the number of pieces in the denominator? What happened to the number of pieces? And the number of pieces in the numerator? What happened to the size of the piece? Are all of the pieces equivalent? How do you know? What equation shows that they are equivalent? And how could you tell someone to know? This is like a bonus. Number 5 is kind of a bonus once you get 1 through 4, okay? So these are the questions. Once you find your equivalent fractions for these 2 that you need to be discussing, okay? All right, back to work. 5 minutes. So y'all were saying, where's your 2/3?
4, 6, and 4. Yeah, I see 2 too.
He has this. That's 2/3.
Figured it out.
Okay, so you have 2/3. What are you trying to do over here?
I figured it out. 2 6 is the 12.
So how did we show that this right here was equivalent to 12 12? What did we do to this to show it was 12 12?
Fraction found
Equivalent.
2/3.
What did they do with all these little
Yeah,
pieces?
we just did
So
that.
2 6.
They covered it up. I wonder if we can use the same thought
Four,
process to
six,
find an
and
equivalent
12.
fraction to 2/3.
No, it's not.
I mean,
Are there any pieces you can cover it up?
wait,
You can help us find some pieces
if we
to
did
cover it up.
that one, then this would have to be 412.
This would
So
be
you got your 2/3? Are you showing what equivalent? Help him show how to model that. All right, talk to me.
4 6. 4 6. So we have that. But now we need to make
Oh, that you're putting other pieces together? So how does that work? Why does this 2 6 work here? Because it's what?
and that's equivalent to it.
2 6 right
Yeah.
here.
So what's the word we're talking about today and using today?
It doesn't say
Equivalent.
It says
Look at that.
2/3.
That's what I said.
No, and then on the second one it says 2 6.
What's equivalent
2
right here, y'all?
6.
Look at his model. Look at his model. What's equivalent right here? What are these 2 6 equivalent to?
This
1/3. Do y'all see that? How do we know they're equivalent?
is look.
It covers the same
This
area,
is
right?
4
So
6. Okay,
if
this is
1/3 is 2 6,
This would be this whole.
This is
how many, remember our fraction that we're trying to find
I'm
equivalent
not
is
doing
2/3.
that. We literally put
How are we gonna find
412.
2/3?
That's not right.
1/3 is 2 6. How much is 2/3?
Something that's equivalent to 2 6.
Yes.
Can you show with your model?
Yes, it is.
Here's 1/3.
6 times 2 multiplied by 2. 2 times 2 is 4.
She said
Can you write that on your board? Can you model what she just said?
Yes, that's
She said 2/3 equals 4 6. Can you show that with your models? Show me her 2/3.
These are 2 6.
These are models. So can you show me 2/3?
Because this
We're trying to find an equivalent fraction for 2/3.
right here
With
is
your
2
fraction.
is equal.
Which fraction piece represents a third?
I was talking about this the whole time.
Which one of these pieces represents a third?
No. 412. Right there. Yes, it is.
This one?
Yes,
How do you know that
it
represents a third? So show me. Tell me your name again. Mel?
is. See, yes, it is.
Mel is saying that this represents a third. You guys help me? Or help him with that, give him some feedback?
Yes, it
Mel,
is.
how do you know this represents a third?
It says 2 6.
Oh, a half. How do you know it represents a half? Ah, it takes 2 of them to cover it, right? So which one represents a third? No. What color? The blue. Why does the blue represent a third? Same thing. That's exactly right. So we have 2/3. Here's your fraction, 2/3. Now, we want to find an equivalent for that. Can you guys help him show how to model this? He has 2/3. How's he going to model an equivalent fraction for that? What's he going to do? Talk to him. See if you can help him out. How's it going over here? You have your equivalent fraction for, ooh, tell me about this model. Uh-huh. So, okay, there's 2/3 under there. I see that. What was on top of it? Yeah. So can you put them back on top of it? I want that model. Oh, do y'all see that? How does she know that 2/3 is equivalent to 4 6? How many 6 did you put up here? Uh-oh. How many 6? Yeah. So how many 6 are down here, though? Let's count them. Remember how we counted 6 earlier? Let's count them. 1, 2, 3, 4. How many 6 are there? 4. So yeah, you want to change that. How does she know that they're equivalent, y'all?